So the first application example that we'll look at, this was a graphite anode sample that had known contaminants that were stainless steel powders. So we analyzed this anode with a 1 millimeter by 1 millimeter elemental map with a 20 micron spot size that we did very quickly. It took about 2 minutes. And you can see how there is relatively high amounts of carbon shown in blue and bright blue. That's what we would expect on a graphite anode, which is mostly carbon. But what we identify on the chromium map is a couple of discrete areas with relatively high concentrations shown in those brighter blues. So what we did was, again, a secondary map with a smaller spot size and higher resolution. So in this case, about a 0.5 millimeter by 0.5 millimeter area with a 15 micron spot size. And we can very clearly see that there are two distinct particles with high chromium, high iron, high nickel that correspond to that expected chemistry of these 316L stainless steel powder particles that we knew were on this graphite anode. So this demonstrates the technique's ability to reliably measure the chemistry of contaminant particles. But what was unexpected in this study was this third particle that you can identify on the nickel map that does not have high chromium, doesn't have as high of iron. And so because of the advantage of the time of flight, where we're seeing all of the elements, whether we want to see them or knew to look for them or not, we can then take a look at those other elemental maps and see that we've got high lithium, manganese, and cobalt in that third particle that we've highlighted in red. And based on that chemistry, we determined this was actually an NMC cathode particle. So an unexpected contaminant particle was identified by this technique. And again, because you have the advantage of measuring the full chemistry down to the parts per million constituents, you can get a very detailed picture of what your material is that can be very helpful when you're trying to figure out, okay, yes, I know I have a contaminant here. I identified it with an optical technique, but what actually is this? Which tool did this come from? And that's where this technique adds a lot of value, is by giving you that full chemistry picture of that contaminant, helping you diagnose where it came from and prevent it from occurring in the future.